And the more we study them, the more we can decipher how life came to be. And Trojan asteroids are particularly fascinating. Throughout the show today, I'm going to meet up with some special guests who can tell us more about the Trojans. But in the meantime, this might be helpful.
What are the Trojan asteroids? Well, let's begin by going back over 4 billion years when the newly formed solar system consisted of trillions of tiny little rocky and icy objects. Many of these objects came together to form the planets. The majority of the others were scattered into the distant reaches of our solar system and beyond, but not all of them. Some of them are pristine asteroids that now orbit with Jupiter in 2 huge swarms leading and trailing the planet. They're known as the Trojan asteroids. They're really, really mysterious, and we think that they come from the outer solar system. They're also really special in terms of understanding the evolution of the solar system and understanding the evolution of the planets, because they have remained gravitationally stable for over billions of years. And astronomers have only been able to study these distant and enigmatic small bodies from Earth. But all of that is about to change. NASA's Lucy mission will embark on a 12-year journey to visit these primitive asteroids. And it's going to be really exciting because it'll be the first time that we are able to see these objects up close. So what are the Trojan asteroids? They're asteroids that orbit with Jupiter around the sun that ultimately hold the clues to the formation of our solar system.
And I bet some of you at home have even more questions. That's wonderful. We want them. Please send them in. Just remember to use the hashtag AskNASA or drop those questions in the comment boxes wherever you're watching this show. But I actually have some questions of my own, and that's why I have these two joining me here today. This is Dr. Carly Howitt. She's the Assistant Director of the Department of Space Studies at the Southwest Research Institute. That is a mouthful.
Sorry about that.
And Will Santiago, Deep Space Exploration Engineer at Lockheed Martin Space. Thank you guys for joining me today.
Thanks, it's great to be here.
Absolutely. And now I want to talk about the fact that, NASA has visited asteroids before. We even have a bit of one coming back to Earth as we speak. What's special about Lucy is that Lucy is not just visiting one asteroid, not 2, but a record-breaking 8 asteroids. Carly, can you tell me why that's significant?
Well, we don't know much about Jupiter's Trojan asteroids, and so by going to visit a large number, 8 asteroids in total over the mission lifetime, we'll really better understand all about the asteroids. So if you only see one, maybe you got sort of a bit of a funny one, right? But by seeing 8, you get to really understand what's going on in this population. It's really exciting. We're going to see them up close, understand their color, their composition, try and look for what they might be like inside. We're going to learn so much about the asteroid population as a whole throughout this mission.
Absolutely. And Lucy is interesting because it ties into NASA's overall asteroid research. Can you talk to us about those other projects?
Yeah, so there's a lot going on in asteroid science right now in NASA. So of course, the OSIRISRex mission is bringing back a sample of an asteroid. So that's en route. And there's going to be the DART mission, which is going to try and redirect an asteroid. And then Lucy has a sister mission called Psyche that's going to go to the asteroid Psyche, which we think is a remnant of an older asteroid. So it's a metal core. We think previously it might have been a larger planet that had the outsides blown away, and we're going to look at the inside of this asteroid with that mission, and it's just going to be a great few years for asteroid science.
It's really fascinating, and I love that there's so much going on with asteroid research. Now, Will, Lucy is set to launch tomorrow, 5:34 a.m. Eastern Time. Soon after, we're going to see her 2 very large solar arrays deployed. Why are they so big?
Well, we were talking a little bit earlier about breaking records. So Lucy's going to be the record breaker to the Juno spacecraft that's currently orbiting Jupiter, that is going to go further away on solar power than ever before. The Trojans are very far from the sun. So we have over 70,000 solar cells that give us the energy that we need to run the instruments, run the spacecraft. You know, out there at that distance, we run the spacecraft with about 500 watts, so much less than the power, you know, we could not run a microwave out there.
Wow, that's really interesting. I think to put that really puts it into perspective, right? How far it's going to be from the sun and how much power it actually has to work. Now, you know, those were my questions, but I hear we're getting some really interesting ones from viewers, which is wonderful. Keep them coming. Again, a reminder, use that hashtag #AskNASA or just drop them in the comment box. I promise it'll be Will and Carly answering those questions. I will bring them back later in the show because I know I will not be able to answer all of your questions. In the meantime, what do you say about taking a closer look at the rocket that's going to launch Lucy? Take a look at this video now by my colleague James Traley.
Oh my gosh. All right. We are just around the corner right now. I just got like a little glimpse of the launch pad. I can see it right here in front of me. Oh, wow. It's right there. Oh my goodness. All right. We are literally like maybe 300 feet away from the Lucy spacecraft on the Atlas V rocket. From what I understand, I think we're going to be actually taking an elevator up to the top of this launch, or the VIF, the Vertical Integration Facility, to see Lucy up close, and we are some of the last people to be seeing Lucy before she blasts off into space. It's a long mission ahead, and yeah, super thrilled to share this moment with you and take you along for the ride. How's it going? So nice to meet you.
It's going good. Good to meet you as well.
Thanks so much for taking us around. This is incredible. This is insane. Oh my God.
I mean, isn't that just a cool? I mean, this rocket is massive.
Yep. Yeah, the scale of it. I mean, 200 feet tall. Yeah. I'm joined today by Isaac and Danya, and we're standing directly in front of the Lucy spacecraft atop an Atlas V rocket. We were just talking on the way up about the scale of this thing. It's really pretty impressive to just take a step back and appreciate the sheer magnitude and scale of this rocket. So can you tell us a bit more about the dimensions of this thing and kind of what is all powering Lucy on its journey out to the Trojans?
Yeah, so Lucy's actually right now sitting on our 401 Atlas V configuration. Fully stacked to the top of the payload fairing. It's about 190 feet tall. So we have the entire vehicle right now sitting on our mobile launch platform, 1.3 million pound steel structure. We have our Atlas booster, our single engine Centaur, and then the Lucy spacecraft on top of that.
And the Lucy spacecraft, it's not a small spacecraft itself, it's pretty large as well, right?
No, it's not a small spacecraft. It's about the size of a standard car. It weighs 3,300 pounds, and half of that is the fuel.
The fuel.
And so, I want to talk a little bit about the solar arrays.
Yeah, that's what I was interested in.
With the solar arrays stowed, they're about 4 inches thick. But when they're deployed, they're 7.2 meters in diameter. So if you were to take the spacecraft with the solar arrays deployed and tip it on its side, it'd be as tall as a 4-story building.
And why do the solar panels need to be that massive? They're specifically designed for this mission for this exact reason, too.
Yes, so Lucy is going to travel 4 billion miles through its journey, its 12 years journey. And it's traveling far from the sun. As a matter of fact, it's going to be the farthest spacecraft traveling on solar power. And so that's why we need massive solar arrays.
And so, I mean, it's a long journey ahead, 12-year-long mission, but there's already been quite a journey on the back end here just to get us prepared. Can you walk us through, I guess, the past, 14 months during the pandemic here? Well, how's it been?
Quite exciting. So we actually started spacecraft integration and testing in July of 2020. Think about it, 14 months to fully integrate the spacecraft and the payload, the instruments, during a pandemic, testing it through an entire environmental test campaign, which simulates space, which gives us confidence that it's going to survive the full mission.
That's amazing. Yeah, and then also just the journey to get the spacecraft from all its individual parts assembled on the C-17 that you got to ride with, and then to here. I mean, what's been the process like on the ground in KSC?
Yeah, so once we landed, we had about 7 weeks in which we reintegrated hardware like the high gain antenna and updated flight software. and did functional testing to verify that we didn't break anything during shipment.
It's important.
And then we fueled the spacecraft and did our final on-pad functional. And the spacecraft is currently powered up, and we're monitoring it state of health 24/7 through launch.
And then what is it going to be like the day of the launch as well, kind of getting the spacecraft ready, really long before sunrise even, to get it ready to...
Yeah, so our crew will actually be coming in 10 o'clock the night before for our, yes, exactly, for our pre-launch securing. So we'll go through all of the final closeouts at the pad, our final pad preps, pulling the cover over the flame bucket where the exhaust will go for launch, doing all our final preps, and then clearing the pad at roughly 2:30 in the morning so we can go into cryogenic tanking. And then at liftoff, 860,000 pounds of thrust at sea level will take Lucy on its journey.
And then we're on our way. I mean, it's a 12-year-long journey, and we were just talking about this on the way up.
Yeah.
It's super exciting, obviously, a long mission ahead, a lot of really cool discoveries waiting for us out there. But at the same time, I mean, a little bit of sadness here, because this is the last time that we're going to be this close. Humans are going to be this close to the Lucy spacecraft.
It is. I mean, as the project manager, right, my 10-year-old Lucy is going to be ending soon, so it is a little sad, but it's also exciting. It's exciting, and I will be waiting with bated breath as we encounter those Trojans. I know what we think we're going to find, but I'm excited for the new discoveries, the unexpected. That's what I'm looking forward to. And we'll be following this mission and waiting for it to rewrite our science books.
Yeah, and obviously not your first rodeo. You've sent many missions up to space. What, I mean, keeps it exciting? What keeps you coming back every single time to launch another mission up on the Atlas V?
It's something where you'd think it would get routine and benign, and it's just every mission, every launch, that final countdown, if you're not getting butterflies, then you're in the wrong business.
I mean, the view alone up here, just checking it out before, I mean, it's exciting, kind of just taking it all in and just...
Enjoy what you see and take pride in all the hard work that folks, everyone, have done to contribute to the success of this mission.
It takes thousands and thousands of people to get us to where we are today, from all the different teams, all the different organizations. And on top of that, it's something that beyond those that directly contributed, it's something, a mission that as special as this, that really everyone is able to share a part of and everyone's able to follow for its entire journey. So it's something where even people at home can experience the launch, experience the mission, and follow along with it. It's really special.
Wishing you guys the best of luck, and I want to thank both of you for taking some time out of your incredibly busy schedules here. You know, we're just
pleasure.
Hours, I guess, away over the next couple days here from Lucy blasting off away from us. So thank you both. Congratulations on all that's happened so far, and best of luck over the next 12 years on this long journey.
Thank you very much.
Thank you so much.
Thank you.
Appreciate it.
If you are just tuning in, we are live from Kennedy Space Center, just 12 hours away from NASA launching Lucy, the first spacecraft to visit the Trojan asteroids to hopefully unfold the story of our solar system. As you know, Lucy is on a 12-year mission. So that means we really need to start thinking about training the next generation of scientists and engineers so that hopefully they take on those leadership roles as Lucy progresses. And that's why NASA created the Space Academy, a free online interactive program open to undergraduate STEM students. And actually joining me today are two former La Space Academy students. Brittany, Wilbert, nice to have you here.
Thank you for having us.
Awesome. Well, talk to me, Brittany. I'll start with you. Talk to me about how it felt to be part of La Space Academy.
The Space Academy is absolutely amazing. I think it really transformed just the way that I view life. I was tested not only in terms of writing technical papers, but also in terms of combining engineering with creativity, which I think a lot of engineers sometimes might find hard to do.
Yeah.
And I feel like I also was able to just cultivate a space of mentors and a space of just a community that really wants to see me succeed and really wants to see each other succeed. So being able to go through the program as a student and now turning around and being a mentor, it's kind of crazy imagining that I can impact people's lives in the same way that they've impacted mine. Overall, I think LaSpace has just had literally a tremendous impact on my life, and it jump-started my my career, which was insane, but it also really had a heavy impact on my personal life and my academic life, so it was life-changing.
Yeah, that's beautiful, the way that you said that. And Wilbert, do you kind of share that same life-changing
Absolutely
feeling?
life-changing for me. I was actually part of the first ever Space Academy back in 2018, and I've been waiting for this day, the day before launch, for 3 years now.
Wow.
When I was in this academy, I was in my second year of school, and that's when I started learning about what takes it to design and fly missions to space, and that really gave me a scope that I didn't have before. It gave me those skills and knowledge that I have been implementing in my career now. It also provided me with my first NASA internship working with the NASA Lucy mission, and it also allowed me to share my passion for space by being a Lucy Asteroid ambassador and communicating the great science that's going to be done by this mission in the coming years.
Yeah, it sounds like it really opened a lot of doors for you. And speaking of in the coming years, right, in 6 years, August 2027, that is when Lucy is going to encounter her first 2 asteroids. Where do you think you'll be when that happens?
Well, thanks to the Space Academy, I think I'll be designing, building, and flying my own missions, at NASA or another company. And I'm also going to be looking forward to what Lucy is going to discover in the Trojan asteroids.
Yeah. And what about you?
I think I'm definitely going to be following up on the science of Lucy because it's impacted not only my life, not only the creation of the Space Academy, but also the lives of the countless people that have worked on it. So I'm definitely going to be following up. As for myself, hopefully I'll have a PhD or a master's, not really sure which one yet. And hopefully I'll be making the next Lucy. And if I'm not doing that, I'll be an astronaut. Preferably, I'd like to do both, maybe at the same time. You know, for so long, I thought that my dream of being an astronaut was so unattainable, but being here not only physically for the launch, but also just in the presence of so many smart and talented individuals that not only worked on Lucy, but the people that watched the creation of Lucy and followed up on the NASA news as well has just made me realize that all of my dreams are even closer to being reality than I realized.
I believe in both of you. I think you both are going to accomplish some amazing things. It gives me goosebumps listening to it. So no, this is really wonderful. And you know, it still just really blows my mind that there are students in middle school classrooms right now that could be taking part in Lucy. For kids that might be watching this, you know, what advice would you give them if they think that this might be an opportunity they want to pursue?
I think that's a great question. I think it's a little hard to give advice, especially because I'm so young myself, so I feel like I'm figuring it out most of the time. But I will say that one thing that I've learned in my relatively short 21 years of life is that the environment that you're in really shapes the way that you think, and it really shapes the way that you navigate the world. So I would say to young kids, if they're able to find a teacher, or find a parent, or find a friend's parent, or a friend, whoever, just finding a group of people that are going to support you and your dreams and your passions, and the people that are going to tell you to keep going, even on rainy days, they're going to remind you that the sun is going to come out again. I feel like cultivating that type of community is extremely important, as well as just making sure that you have people who teach you how to have grit and teach you how to have perseverance, you know, and just kind of keep you going even through the tough times, because STEM is very hard at times, even though it's very rewarding. And I feel like I've definitely kind of had that in my own life. I mean, I never thought that I would be here talking for a NASA program. I never thought that I would even have the opportunity to work at NASA's Jet Propulsion Laboratory, and here I am. So I hope that young people are able to look up to me, especially my young black girls. I hope that they see themselves in me and know that if I made it, they definitely can make it too.
Yeah, it's good to have that support system. Will, would you say that that's important as well?
I definitely echo those same feelings. Being a Latino and, you know, being in space is really important to me. Through the Space Academy, I have been able to get to know a lot of people in space, such as Will Santiago and some amazing people that come from Puerto Rico and other countries. And I've also found a lot of support, people that have allowed me to persevere, to move forward, to achieve my goals, being my mentors here and there. And I think that the best advice is the one that she gave, and it's, you know, to find people that have your same passions, but also have different life experiences. I found that when you have multidisciplinary teams, people that come from different countries, different academic majors, you will have a better team and a better product, a better system, a better mission. And that is, you know, crucial for everything, both in space and on Earth. And just to, you know, live your life and achieve your dreams and work for it every day.
Yeah, diversity, different perspectives, it's so important, and I'm glad that both of you really pointed that out today. So thank you so much for the great advice.
Thank you for having us.
Go Lucy, that's right. And you know, you heard them, really think about it. Lucy is, again, a 12-year-long mission. So if you're an undergrad, or if you're in high school, or if you're even in middle school, there might be an opportunity for you. So look up at your screen right now. Take a look at what's on the screen. It says lspace.asu.edu. Check out that website. Again, it's the letter L, space.asu.edu. So launch tomorrow, just the beginning, right? Let's find out what happens to Lucy after she lifts off the launch pad.
NASA's Lucy mission is going to be the first mission to explore the Trojan asteroids. These are asteroids that live in two swarms, one that's ahead of Jupiter and another that's behind Jupiter. And we want to go and look at these building blocks of the planets, the ones that didn't get accumulated into the planets, to really learn about the evolution of our solar system. Early in the solar system, the giant planets were migrating outward, away from the sun. And at one point, there was chaos in the solar system. Some small bodies were ejected out of the solar system. Others could have been trapped in these Lagrange points. And that's one theory for how the Trojan asteroids came to be where they are today. Lucy has 3 scientific instruments on board the spacecraft, and we'll also be using 2 of the spacecraft subsystems to contribute to the science investigation. With the LORRI instrument, we'll be able to get panchromatic images, which will tell us about the geology, and the crater history, which gives us the age of the surface. With the TESS instrument, we'll be able to measure the temperature of the surface at different points. And with the RALPH instrument, we'll be able to measure the composition of the surfaces. We really have never seen Trojan asteroids up close before, and we want to understand their geology, look at the craters on the surface to understand the history of their surfaces, understand the composition of their surfaces so that we can maybe learn something about where they formed. And all of those will be clues to help us understand how the solar system evolved.
As promised, I'm back with Will and Carly to answer some of your questions, and you can actually keep the questions coming. Just remember again, hashtag #AskNASA or drop them in the comment box. We have a team of people monitoring those so that we can get as many questions as possible during this show. Okay, our first question. You guys ready?
Let's do it.
More enthusiasm, guys. More enthusiasm. Gretel on Facebook asks, why is the mission named Lucy?
That's a great question. So most missions are acronyms or something like that. This is just Lucy. It's a name, and it's in reference to the hominid that was discovered in Ethiopia by Donald Johanson. And this fossil was really important to understand how humans have evolved, right? It was sort of a missing piece in that fossil record. And Lucy, the spacecraft, is going to go and look at these Jupiter Trojan asteroids. And we think it's going to discover and understand these sort of fossils of solar system formation. So it's a little bit of a sort of a nod towards the Earth archaeology as we go and do our space archaeology.
Yeah, I love that tie, and I think it's so appropriate. We also have Wendy on Facebook. What do you hope to learn from this mission?
So much. I mean, we're going to these asteroids, right? Because we've never been there before. It's like going to a totally different world. We're hoping to learn about the composition. We have these instruments on board to give us that scientific data. Composition, like things like the surface properties, the temperature of these asteroids. Potentially, is there water ice or other types of exotic ices?
Yeah.
And that will tell us really about the whole solar system history and the formation. Where did the asteroids form? What those main ingredients were so early on, 4 billion years ago in the formation of our solar system.
And why do you think it's so important to understand how our solar system formed?
It's part of our history, right? Understanding how solar systems form, what those ingredients that created our planets, especially the outer planets. It's like going back in time. These asteroids are time capsules, right? As Carly mentioned, discovering that fossil told us a lot about our human history.
Right.
So understanding these asteroids will tell us about how solar systems form, calibrate our models, and potentially tell us how other solar systems form in our galaxy and beyond.
Yeah, there's a lot we can learn from Lucy. And Abby on Facebook asks, will Lucy have the ability to redirect or make course adjustments should there be any unforeseen object or hazard once separated from the Atlas and in full flight?
That's a great question. So we are going to a region of space that we've not explored before. So of course, that whenever you explore somewhere new, there are some hazards. We've been looking at this region of space since Lucy was selected with the best telescopes we have. So we think we have an idea of what the risks are. As well mentioned, we had these enormous solar panels, and so moving that sort of big mass is going to be really difficult. So there are things that we can do. We will be looking ahead with our camera systems to see if there's anything, but it is going to be difficult. We're not going to be doing a U-turn, let's just put it like that. But, you know.
A U-turn is not easy in space?
No, a lot of planning required for that.
And actually, a follow-up to that, will Lucy be able to adjust to different target asteroids? Is that the same thing, like the way that she can't change her trajectory in a wide way, like you can't make those little adjustments to maybe add in more asteroids?
So the nominal mission's already been set, so the next 12 years, we know what targets we're going to see. The bonus asteroids might come in if we discover maybe some of them have moons, and we've already done that once. Eurybates, which is Lucy's first target, has a moon discovered that only a few years ago called Kita, and so when we fly past Eurybates, we get a bonus moon. So maybe we will be seeing more asteroids up close if they have moons. After our nominal mission, if everything works, we'll be applying, I'm sure, to see more asteroids, and we'll do some maneuvers called TCMs, trajectory correction maneuvers, to allow us to do other flybys. But whenever you do that, you burn fuel, and so that's a limited resource. We're very careful with that.
Gotcha, gotcha. That was a good question, though. And Carol on Facebook asks, the dedications on Lucy to the people who have been so involved with the project are very touching and bring everything back to the human scale. Do you do this on every mission?
We try to, yes. There's Legos, for example, on the Juno spacecraft representing the goddesses and the gods. We try to make it fun, right? You know, these are human missions to us, right? They're robotic missions, but they're human missions. People spend their careers on this, right? So we're trying to make Lucy this cool time capsule that maybe the next generation can find orbiting, you know, that awesome, beautiful orbit that is part science, part luck, it's part art. So it's amazing, you know. We like to have fun, and we like it's an amazing team, and we're really proud to be part of it.
Yeah, absolutely. Guys, I'm so excited for you to get to see this come to fruition after so much hard work. So, Judy on Facebook asks, what is the timeliness for data being transmitted back to be analyzed? We have a 7-year-old granddaughter named Lucy, that's amazing, who is eagerly following this mission, as she should, obviously.
Absolutely.
So yeah, what's the timeliness that you might get some data back?
So the quick answer is it depends where we are in the orbit. So Lucy launches, and then we do 2 Earth gravity assists. So when we're very close to the Earth, it's very quick to get data down, of course. The further we go, the longer it's going to take to get that data down. So as we move through the Jupiter's Trojan asteroids, it's going to be even a little bit longer, but it's quick by outer solar system standards. So we'll be getting probably images of Earth's moon during those gravity assists. We're planning them right now. So that'll be down within the next year. So we're expecting there to be a little bit of a delay. It does take time to bring the data down, but we'll be starting seeing data from next year throughout the mission.
Oh, wow, that's amazing. Shazar on YouTube asks, what do you expect to find out about how the planets formed? Any guesses?
So we're going to learn a lot about the composition, and that's going to tell us sort of a lot about what was available in that region of space when these bodies formed. They're pristine objects. They haven't changed, we think, since they were formed. And so the only things that they have to be formed out of is what was in space when they formed. There's 2 ideas. One is that they formed deep out in our solar system in the Kuiper Belt. So think Pluto, right? A very, very long way. And then there was this whole like cosmic billiards game, and they got kicked into the inner solar system and captured by Jupiter. So we might be seeing ices that are more similar to what we see in the Kuiper Belt, or maybe they formed where Jupiter is now. We'll be seeing compositions and ices a lot more similar to, say, Jupiter's own moons. So one of the things is just learning what they're made from, and that's going to be really exciting.
Yeah, the unknown, right? That's what we're...
The unknown.
That's a tall order to figure out. Abby on Facebook, NASA has an incredible track record of rovers, orbiters, etc., still being operational past the prime mission. Are there plans for Lucy should this be the case once all the target asteroids have been studied? That's a question for you.
Yeah, here's the amazing thing about the Lucy trajectory, right? It's part luck, part accident, but it's going to be in this stable orbit between the Trojans and Earth for millions of years, right? So it depends on the systems, right? As you mentioned, a lot of the missions get extended. So we'll evaluate if are there target opportunities, do we have enough fuel on board, are their systems okay, are their instruments working as expected? This is a long journey, right? We're super excited. We're going to be operating Lucy for 12 years. So we'll see at that time. We're looking forward to the science that we get back.
Yeah, I think you mentioned earlier, you know, it might just be cool for somebody years and years and years from now to find it, like as something that just is representative of the early space exploration we're doing now. Sockfevel on YouTube. Why does the Lucy mission take so long?
So outer solar system science takes a long time, and anyone that's worked in the outer solar system knows that you have to learn patience. It took 9 years for New Horizons to get to Pluto. So 6 years isn't actually too bad by outer solar system timescales, but we just learn. Things are a long way away, and it just takes time to get to them.
Yeah.
You know, obviously the quicker you go, the quicker you get there, but then the faster your flybys are. So there's a trade between how quick you want to go, how quick you want to get there, but also how slow you want to go. You want to see the things as you pass them, right? So there's a little bit of a trade space there too.
Right. Philip on YouTube wants to know what time is liftoff, and I do also want to take this opportunity to talk about what if there's a scrub tomorrow. It doesn't look like it, honestly. The weather looks fantastic tomorrow, but what if there's a scrub? You know, what are the opportunities to launch?
Yeah, so we'll be launching at 5:34 Eastern time. The window is about an hour long. But we have the opportunity for the next 23 days, starting tomorrow, to launch Lucy. And the importance there is the energy of the rocket to get us into that right awesome trajectory to go visit all these Trojans. So hopefully the weather is super awesome tomorrow. We're ready to see it go. The rocket's doing great. The spacecraft, it's doing amazing. But yeah, we have 23 days to launch Lucy in the next few days. If that opportunity doesn't happen, we have an opportunity about a year from now.
Okay, gotcha. So there are opportunities, but I'm really keeping my fingers crossed for tomorrow, right? Well, everybody
Absolutely,
is?
absolutely.
Isaiah on Facebook. How do you get the gasoline to stay preserved on the long journey?
Yeah, so we have quite a bit of fuel on board. It's about half of the mass of the spacecraft, and we need that fuel to target the Earth, right, and target the trajectory as we're going out there. But the fuel's liquid. It's almost like a little bit like water, so we have to keep it above freezing all the time. So we maintain it with electric heaters and blanket and insulation. Space is really cold, but we also have to maintain it cool, so we get a little bit close to the sun. So the spacecraft is designed to manage all that balance of energy coming in and out, as close as we get to the sun and as far away as we're going to the Trojan distance.
I'm sorry, you figured all of that out in 14 months that you built this thing during a pandemic? Is that what you're just telling me right now? That's amazing. I mean, the solar arrays, and then just even, that was a great question, because I didn't even think about that.
Yeah, it took a lot of team effort to put Lucy together in these 14 months, and it was a challenge, right? We have to keep the team safe, protect everybody, so it's amazing team effort, and an honor to be part of it.
Yeah, high five. Good job. All right, Caleb on Twitter, is there any form of geological activity on asteroids?
It's a great question, and the answer is we don't really know. So, of course, we saw Bennu up close with OSIRISRex, and it looked like there were some things flying off of it, but we sort of think that might be meteorites coming in and making things fly off. So not activity from the core, but sort of a response to being bombarded. But that's one of the things we're going to be looking for, and we actually have a working group dedicated to looking for activity from these. So we don't think so, but if there is ice on there, maybe that is slowly sublimating away and being lost to space. So we'll find out. We'll let you know in 6 years.
Okay, in 6 years, yes. Nobody asked me what I'm going to be doing in 6 years. I don't have an answer as good as the students there, though. All right, Haiti on Facebook. Where is Lucy going on its long journey?
That's a great question. So it's going to launch from the Earth, and then we do some gravity assist. So it'll basically come back to the Earth in about a year's time, and then in 3 years' time. And that just gives it a little bit more energy. We're going to be going faster. And then we spin it out to Jupiter. So we go through the main belt, which is the asteroids that we normally think of. So that the asteroids between Mars and Jupiter. And we see an asteroid there called John Oda Hansen. That gives us a little bit of sort of a test for all of our instruments. We'll be able to take images and just kind of get our sequencing down. And then we're going to move into the L4 swarm, which is really where we get into the Jovian asteroids in about 6 years' time.
Is that what we're approaching right now that we see in the video?
Yeah.
Perfect.
So we're going to be going past our first set of targets in the L4 swarm. And then we're going to loop back past the Earth. We do another Earth gravity assist, which is actually great for a deep space mission because we're going to be able to spend that time downlinking all our data. It traditionally takes a long time to downlink data from the outer solar system, but the closer you are to Earth, the higher your telemetry rates are. And then we'll use that gravity assist to swing into the L5 swarm and do our final set of flybys, which is of two binaries, or a binary pair. So two equally sized or nearly equally sized objects that are circling a sort of central point. And those will be the last targets of the nominal mission. But like Will said, fingers crossed, we'll be doing this for a while yet.
Yeah, I mean, it's such a complex trajectory, and I think that video actually really simplifies it very well for people to understand. So I'm glad we also had that to look at. Okay, Leica on 65 on YouTube. When does Lucy meet up with the first asteroid on its mission? We kind of touched on that, but can you tell us a little more on that?
Yeah, so as Carly mentioned, we have that practice, right? We want to test out all the instruments, all the systems of the spacecraft in 2025 on that Donald Johanson asteroid, which is in our main belt asteroid. The first encounter is actually on 2027, and from there we follow up in a few months with the next asteroids in that first L4 swarm. And then the last one, it's March 3rd, 2033. So that's why it takes so long. It's, as Carly mentioned, long distances that we're going, but we're really excited to get that science back.
Awesome. Nelson on YouTube, what is the possibility of Lucy finding new asteroids that our telescopes have not seen?
It's a great question. So one of the things, although our telescopes on the spacecraft aren't as big as the ground, we're obviously a lot closer. And we'll be doing scans of the sky to just look for that, look for hazards, look to see whether there's anything out there that we can't see right now. So there's a really good chance we'll find more. Every mission, I think, that's gone to any system ever has discovered new things, and I expect Lucy to be the same.
Yeah, absolutely. Pure Spartan 157 on YouTube. Does the Atlas V use a kickstage to get Lucy into an interplanetary orbit? If not, what is the propulsion system that is being used for the Lucy mission?
Yeah, so the Lucy spacecraft has quite a bit of fuel on board. It's a chemical system, hydrazine and nitrogen tetroxide. The Atlas V doesn't have the standard SRB boosters that we typically need. It has enough energy to get us, that high speed to get us on our way. And that's why we're using the gravity assist, right? We need that boost from the Earth. We just don't have enough energy on the launch vehicle to get us that far. So as Carly mentioned, we'll be doing those 2 gravity assists, and that will get us on our way and energize the orbit all the way to the Trojans.
Yeah, that's fantastic. Winton Ashley on YouTube asks, is Lucy going to bring back samples?
No, it won't. So this is purely remote. So you could think of it as like flying by, taking pictures, taking images, but not stopping. We're going to be doing 8 targets, as we've already discussed, and you can't stop, start, and carry on. That's very hard to do in space. So we'll be flying by, doing as much science as we can during that encounter, but then on to the next target.
Yeah, okay. Andrea on Facebook, are there any specific organic compounds that NASA will look for on the asteroids, specifically anything associated with the origins of life, maybe?
So there's an instrument called LISA that enables us to look at the chemical signatures, the chemical footprints of different species, and so it's been tuned to be sensitive to the carbon band. So we will be able to tell different types of compounds on the surface. We think there might be things like ammonia, and there might be other organic ices and exotic ices. We don't really know. They're very hard to look at from the Earth because they're dark, they're a long way away, and to look through the Earth's atmosphere, you're also, you've got to take all the water out and all the other things.
Right.
So we'll finally be able to really see at high spatial resolutions what the ice is, what the minerals, and what the rocks are made of. So we'll know a lot more when we get there.
Yeah, I just think it's fascinating that Lucy is going to find out a lot of information, and we're not even landing on any of these asteroids. We're just flying by them at also a very high rate of speed, right?
Yeah, it's
15,000 miles per hour on average, right?
That's insane.
We're about 620 miles on average from these asteroids, but everything happens so fast. If you look at the 12-year mission, most of the observations and the science happens in that 24 hours out of 12 years. So it's really exciting. We're excited to point the instruments and get that initial data back.
Great.
And we have some practice. So there's a lot of the team that were involved in New Horizons flew past Pluto and Arrokoth. So we have some great expertise on the team that know on a high-speed flyby of an asteroid how to take the perfect picture.
Yeah.
And so we'll be utilizing all of that knowledge, all of that heritage to make sure Lucy returns the best data it can.
That's great. That's great. And then David on Twitter, are there clusters of asteroids at other Lagrange points of Jupiter? And I think maybe explain Lagrange points. I don't know.
Yeah, so the Lagrange points are they're regions of space that are gravity neutral. So where the sun gravity and the Jupiter's gravity cancel out. And actually Earth has them too. It's not specific to Jupiter. It's just this area of space that's very stable. And that's why actually JWST, so the James Webb Telescope that's going to be launched later this year, the follow-on from Hubble, is going to be sitting in the Earth's Lagrange point because it's a stable region of space that it can observe the solar system from. And that's why the Jupiter Trojan asteroids are so special, because this stable region of space has enabled them to remain the whole time the solar system has been forming and evolving. They've been sitting there watching it all happen. So the Earth actually has 2 Trojan asteroids recently discovered. We don't know if they're as stable as the Jovian ones, so maybe they're sort of a transitory thing. But it's a pretty uncommon thing. Jupiter is pretty special to have so many.
Yeah. I have an important question. How are you guys feeling? There's a lot of questions coming in. That's great. Again, keep them coming in. Hashtag Ask NASA. You gotta test these folks. No, that's great. Are you doing okay? Water, anything?
Yeah, we're doing great. These are great questions.
I know these are really great questions.
Insightful,
yeah,
really
I'm
insightful.
very thoughtful. So Jonathan has one as well. Jonathan on Twitter. Will Lucy use a gravity boost from Earth or one of the outer planets to build up the speed for the long trip on the asteroid? We do know about the 3 from Earth. Are we doing that with any other asteroid, as he said?
Nope, just the 3 Earth gravity assists. We're not going to be getting close to any of the other big targets in our solar system.
Yeah, it's interesting because we're actually, when we do our flybys, that's the closest that the spacecraft will be to Jupiter. So that's amazing, right? The Trojans are so far out from Jupiter. But yeah, we're using that energy, as Carly mentioned, to get us there.
Sahas on YouTube asks, what will happen to the spacecraft after its mission? Will its orbit be stable enough? We do know that for Lucy to survive. Is there any other insight you can tell us about what maybe could happen after the nominal mission?
Yeah, it's very interesting. The engineers analyzed the orbit to make sure that it wasn't going to impact anything in over 100,000 years.
Oh my gosh.
But it's going to be in this stable orbit for millions of years. So that's really the exciting part. So hopefully, as Carly mentioned, the spacecraft keeps going and we can do more science. That's the whole point of these missions. It's about to learn more, the origin of our solar system, calibrate our models. It's really exciting. And it's a unique orbit. We got lucky, I think, Carly, right?
It's
really amazing.
Is. Yeah, kudos.
Yeah. And Phil on Reddit actually kind of touches on what you were talking about, Carly. How much of the experience of missions like OSIRIS-Rex has helped the development of the Lucy mission?
Oh, so much. I mean, every mission builds on what's come before it, and we'll be able to put the Jovian Trojan asteroids into a context of wider asteroids as well, with the other missions like Psyche and OSIRISRex that have already flown. And so every time a new mission comes along, there's a technology development that go with it. The solar panels, this isn't the first time we've flown solar panels, and so we've learned a lot from the experience of Juno, and we've gone on, and these are even better. So we're standing on the shoulders of giants, just like every other NASA mission.
Yeah, and I think the 3 of us haven't talked about this yet, but Lucy, yes, is named after the Lucy fossil, but the Lucy fossil was named after that Beatles song, Lucy in the Sky with Diamonds. So Tim on Facebook wants to know, are there diamonds on Lucy when she goes into the sky? Great question.
Yes, there are. So the TESS instrument, which is that infrared instrument, that's kind of like that thermometer at distance to get the temperature of the asteroids, actually has a beam splitter that gets that light, and it's actually made out of diamonds. So there will be diamonds in space.
Isn't that great? I think that's great. I think it just all fits in, right? Like the fact that the name is after the Lucy fossil, and there's a song, and there's a diamond actually on it. It's great. I love it. I love when things like work out like that. All right, Rohan on Facebook. How far are the asteroids?
Wow, they're far, Carly, right?
So they're
very far.
They're at the same distance as Jupiter. So Jupiter's about 5 AU, where 1 AU is the distance from the sun to the Earth. So if you think about how far away the sun is, the asteroids are 5 times further from the Earth than we are. So we're a factor of 4 different, right? So a really long way away from us. That's why it takes a long time to get there, and why it's hard to do this science from the Earth.
Yeah, yeah. Bruce on Twitter, are there any currently classified meteorites that you suspect may have come from the asteroids Lucy will be visiting, similar to the Howardites and the Diogenites? I butchered that, didn't I? Butchered. You know what I'm saying.
Yeah.
Link to Vesta 4.
So some are definitely part of a family. So Eurybates is part of a family of comets. And what that means, we think, is there was a parent comet that got disrupted, and it formed smaller fragments. And those can definitely come out and hit the Earth. I think Eurybates is the best bet, but I'm not sure, actually, if there are on-the-ground examples of those meteorite collection. That would be good to know. I should know that.
Yeah, that was a good question that I didn't know how to read to you. I'm very sorry. Navdeet on Twitter asks, will humans visit Trojan asteroids in the future?
Wow, that's a challenge, right? It's really far out there. For humans to get there, you have to carry a lot of water. NASA's working on missions right now to go to the moon and go to deep space, like Orion. The whole Artemis program, right? Going to send the first woman to the surface of the moon and the next man. So there's plans out there, you know, stations that we can send people out there. We're going to try at the moon and then use that as a stepping stone to keep going further, Mars and hopefully beyond.
Yeah, one step at a time, but we'll get there, I think. Lucy on Facebook, what science instruments are on Lucy and what do they do?
So we have three main instruments, but one of them is actually a bit of a 2-for-1 deal. So we have LaRalph, which is made up of MVIC, which is the instrument that I've been working with the most, and LISA. MVIC is the color camera, and LISA enables us to get our fingerprints, our chemical compositions. So that's a really important instrument, and I've been involved in that. Then there's also LATES, so that's the thermal instrument that we've already touched on a little bit, looking at the heat, the temperature of the comets, the asteroids. And then finally, LORRI. And LORRI is our black and white imager. It's our deep space imager. So it allows, it's kind of like a camera with binoculars behind it, right? We can see very well at very high spatial resolutions during these flybys. And so we'll be using all of those instruments to understand the targets as we fly by.
Yeah.
A great payload.
This one's a good one. Pip on Twitter asks, why are they named the Trojan asteroids?
So I had to look this up because I thought this might come up, and I'm glad I did. So thank you for that question.
Thanks, Pip.
So everything in space has a mythology behind it, and it happens that these regions of these asteroids were all named after characters in the Trojan Wars. So from that Greek mythology. So we call them the Trojans because they're named after characters from the Trojan Wars.
I also looked that up. You are right. I was like, I also looked up how did Lucy the hominid die? Do you guys know that?
Oh no, I want to hear this answer.
Apparently, researchers think that she might have fallen from a tree. Again, this is the namesake of the Lucy mission. I'm not just like randomly talking about things. But yeah, the Lucy fossil. Supposedly, that's how she passed. Yeah, isn't that interesting? I mean, just the fact that this mission makes you think and makes you want to learn more, I think, is amazing. And then Don on Twitter, are there any potential available resources in the asteroids?
Ooh, potentially, right? We're actually bringing the first NASA sample back as we speak, 2023 on the OSIRISRex mission. That was the prime goal of OSIRISRex: collect that sample, bring it back. Potentially resources. We'll have to see. I mean, you heard Carly, right? We're so excited about the unknown. What are we actually going to see in these asteroids? What are the ingredients, the organic compounds? Potentially, you know, for example, Carly talked a little bit earlier about the Psyche mission. The Psyche asteroid is more metallic, right? So potentially there's an industry out there for mining and resources, right, for our special metals and rare metals. So, you know, we're going to learn so much on this mission over the 12 years.
Yeah, absolutely. Now, this is actually the final question. It's from me, sorry. But I want to know, I mean, obviously both of you are very personally invested in this. You spent so much of your careers, you know, leading up to this point. What are you personally most excited about with Lucy?
I think the unknown. Being able to explore is such a privilege, and the unknown unknowns are always the things that get you. You know, you've planned and you've thought about it, and you think you've got an idea of how everything's going to look and be, and then and nature just doesn't do that. You know, it surprises us, and so I'm looking forward to being surprised.
Yeah, yeah. What about you?
Geez, you know, I worked on the Juno mission, right, that used solar power, and we're going to break that record, so it's really exciting to be part of this. And as Carly said, you know, we're going to brand new worlds that no other spacecraft has ever been. So it's going to be full of surprises, but we're ready for the challenge and very prepared. As Carly mentioned, we're going to practice on the Donald Johanson asteroid. So we're planning this mission for that 12 years, and hopefully we get a little bit more.
Yeah, I'm very excited for you guys. I can't wait to hear all the things that you discover after the launch tomorrow. So wonderful. Thank you both for being here today.
Thank you so much.
All right, great. And you know, just thank you to all our viewers at home who tuned in to watch this and for sending in such thoughtful, again, questions for Will and Carly. To learn more about the Lucy mission, go to nasa.gov/Lucy for more information. Again, it's right there on your screen, nasa.gov/Lucy. And you can also follow Lucy's 12-year mission on social media. So you can follow NASA Solar System on Facebook, Twitter, and Instagram. Again, NASA Solar System. Another option is also hashtag Lucy Mission. That's an easy one, right? Hashtag Lucy Mission, again, right there on your screen. And then I want you to take out your phones. You got to set your alarm clocks for the launch tomorrow. Lucy is set to lift off from Cape Canaveral Space Force Station no earlier than 5:34 a.m. Eastern Time tomorrow, October 16th. And be sure to join in with the excitement with others from around the world by registering for virtual NASA Social. There you can connect with us, you can learn more about the spacecraft, and you can even learn how to create your own Lucy time capsule. That's really cool. As always, thank you so much for tuning in, and we will see you next time.